Great, so here's just kind of a little overview of the PicoScope 6 software. So I've loaded this without a device. So this is the demo device it gives you by default. So you can switch on any of the channels, and they have a few different waveforms. And you can actually change, if you open the signal generator right there, you can change, what waveforms you want on each channel, and you can define your own even. So they just give you some basic options. Anyway, so for the PicoScope stuff, let me switch off all but one channel here. At the bottom is where you set up the trigger, so I can set the trigger to auto, and the real scopes may have this ETS, equivalent time sampling mode there. So this is pretty standard. You can switch trigger edge or trigger level, and if you hit this gives you the more advanced trigger options. To get the rulers, what you have to do is, they're just this little point here, so you just pull out that square from the origin. There's only 2 rulers, unfortunately, it seems. I haven't found a reference to having more. Sometimes it would be nice to have more, but so be it. For each channel itself, this little down arrow by everything means there's more options. So for example, here's where you switch the type of probe you have, 10 times probe, 1 times probe. There is the resolution enhancement feature, which uses effectively software to increase your resolution, and it does this by giving you a time average. So if you hit this help, it talks quite a bit about that. So here it's saying, for example, if you increase it by 2 bits, it's averaging 16 samples. Anyway, so I will disable that. So one kind of handy thing when it comes to real waveforms is you can actually put a software low-pass filter. So this just low-pass filters the data, and you can have a huge, well, this probably won't work because I'm sampling so slow here, but if you're sampling much faster, there's 5 gigasamples per second, then it'll let you put some pretty high frequencies here. So this is really nice for cleaning up figures if you just want them to look nicer. That's actually quite a handy feature, especially because it's variable. It's not, there is always the analog bandwidth limit, which isn't in the demo device, but the real devices typically have that. This is also where you would set the analog offset. On the demo device, it actually doesn't seem to work. Maybe I should have used a real scope for this, but I wanted other people to be able to play with this. Oops. And you can also, there's sort of a calibration for the 0 offset. Alright, so you can switch to the different modes. There's the persistence mode, which shows you how it varies, so you can switch the, so you always have this option, so you can change around saturation, the mode, analog intensity, or digital color. So the digital color is probably more useful. The analog intensity is sort of what the old scopes used to be, and of course you have your frequency domain, where you have the various options. So I have some other videos showing you more of those. Down here you have your measurements. So it has quite a few options. It doesn't have everything that other scopes will have. In particular, you may notice that, for example, there's no A to B, so what's the phase difference between A and B, or anything like that. And because we just have the 2 rulers, you can't do some of the more advanced measurements. And there's some additional options for some of them about filtering and whatnot, but that's not too important. One kind of cool thing, though, that is a lot easier, again, because you're on a computer, is, for example, you have this this math channel, and so they give you some simple examples, A plus B, A minus B, stuff like that. But you can use your own to create a your own math-based output channel. So I have one here that was giving me a phase difference between two waveforms. As I mentioned, there was no phase measurement built in, but you can add it through the math channel. So this is pretty cool, and it has all sorts of stuff. So you can integrate waveform, sine, cos. So it's fairly full featured, and it lets you, if you're clever with how you do it, it lets you get quite a bit more out of your scope than you might otherwise. And you can even, somewhere it tells you here, you can add a time delay between channels. So for example, you can subtract one channel from the other with a bit of time delay. This is really handy if you wanted to use two inputs as a differential probe, so A minus B, and I have a video showing you A minus B. There may be a tiny bit of error in terms of either phase or amplitude mismatch between the two channels. So you could actually null that out by adding the appropriate constant in front of, A or B, as well as adding the appropriate time shift. So the math channel gives you a lot of ability to sort of do way more than you might otherwise. And I don't think there's any default math ones besides these, so I'm not sure if you can go online and get more. Up here you have, so with the PicoScope, it has this idea of having multiple waveforms, so it captures the past, and here it's showing 32 of the previous triggers. So this is the idea being that if you caught something once, it may be you're trying to find a short glitch, and it's only in one of these buffers. And you also have them in the other modes. So in the FFT mode, you have the buffer as well. So that's pretty easy. You probably want to do, I like having that properties window open, so you just right click and view properties, and this lets you really quickly see the actual sample rate and the actual number of samples you're collecting, because you can request a number of samples, but it can't always acquire that exact amount. So this has just been sort of a real quick overview of what's in the PicoScope software. So there's a lot more things. There's the serial decoding. I have a video of that. There's masks. You can record macros, and you can also set up things with the keyboard. So I use this with my encoder board that there's another video about. And actually, one thing I forgot to show you quickly was this idea that it's pretty cool. You can have a whole bunch of viewports. So you can decide that well, I want. Sorry, I need to add a new scope is what I wanted to do, and I can just drag that scope over here, and I can decide what channels I want to be on each one. So let's turn on a few channels, and I don't want this so cluttered, I just want channel B there, and I want channel C here. Oops, I screwed that up, didn't I? Let's put channel B here, not C. And then you can say, well, actually, I also want a FFT. So you can add an FFT somewhere. I know you can. Oh, there we go, add view. Spectrum. Okay, so there we go. So you have a spectrum, and you can configure the spectrum again. That's not very interesting. So only channel B, and then when I'm selecting here, I can configure the spectrum within channel B. So the whole thing's really nice in that you have these multiple viewpoints, so you can actually really see what's going on without having to play around with all sorts of offsets in the system. So that's just another nice example of having the PC-based scopes, which I've personally always liked. So I've copied this to the background here. I've always liked just for this reason, that you have so much more room, and if you have a large monitor, not a problem.